Hello student, I am Praveen Kumar from ABS Engineering College, Ghaziabad. In this video, we are going to discuss the working of synchronous motor. Synchronous motor is a doubly excited motor which operates at a constant speed. By saying doubly excitation means this synchronous motor, there are two types of supplies connected. In synchronous motor, there are two types of winding. One is armature winding, which is placed on the stationary part of the motor or stator. This armature winding, basically it is a three-phase winding, which is energized with the help of three-phase AC supply. And the rotor of or rotating part of this synchronous motor consists of field winding, and this field winding is energized from DC supply. So AC as well as DC, both these supplies are given to this motor. That's why this motor is doubly excited motor. And this motor is not capable of developing its starting torque by its own. So synchronous motor is not self-starting. This can be explained in this slide. As we have discussed that armature of the synchronous machine is energized by three-phase AC supply and field of this machine is given by DC supply. So when the rotor of machine is at rest and field and armature windings are energized simultaneously, what happens? The armature windings, when they are energized by AC supply, the polarities of the armature poles, they are changing with every half cycle of the supply. Here we can see that in this case, say this is case 1. In case 1, the upper pole of the armature windings or this stator, upper stator pole is south pole and the bottom side we are having north pole. But as during the next half cycle of the supply, the polarity of stator poles is reversed. Now north pole is on upper side and south pole is on bottom side. Whereas on the field winding, which is placed on the rotor side, we have connected DC supply. As DC supply is given, that's why the polarity of field poles is constant. So with this DC supply, this is the north pole of the rotor and this one is the south pole of the rotor. Now for positive half cycle, we can clearly see that north pole of the rotor is attracted by this south pole of the stator, whereas the south pole of the rotor is attracted by north pole of the stator. So in this scenario, the force of attraction is taking place and the rotor is going to experience torque in clockwise direction. As in the next half cycle, the polarities of the stator poles is reversed. Now the upper pole is north pole and this bottom pole is south pole. Now in this scenario, what happens is here the north pole of the rotor will get repelled by this north pole of the stator. Whereas similarly, the south pole is also get repelled by this south pole. So ultimately, due to force of repulsion, now the rotor is going to experience torque in anti-clockwise direction. As normally a supply frequency of 50 Hertz is connected in the stator windings or in the armature. So we can say that in a single second, 50 times, the direction of torque is reversed on the rotor. So due to this, such a rapid reversal of torque is not possible in the rotor, and due to moment of inertia, the rotor will continue to remain at rest. So we can say that When both these supplies are connected simultaneously in the synchronous motor with its rotor is at rest, the motor is not able to develop its starting torque. So this motor is not self-starting in nature. Now, the principal operation of this motor is explained that both these supplies are never connected simultaneously. For the operation of synchronous motor, first its armature windings are energized by the three-phase AC supply, and then this rotor is made to run at synchronous speed by some external means. The external means with which this rotor is rotated to synchronous speed are considered as its methods of starting. Now, once the rotor is starts rotating at synchronous speed, at that time the field winding of rotor is energized with the DC supply. So, in this situation, the stator magnetic field and rotor magnetic field, due to force of attraction, they interlock with each other. Now, after this interlocking or synchronization of both these fields, if the external force from the rotor is removed, but due to the magnetic locking between stator and rotor magnetic field, the rotor will get a drag, and due to this magnetic drag, rotor will continue to run at synchronous speed. So, this is how, due to magnetic locking, this motor operates. The same magnetic locking is explained in this diagram. Here, as we know, the rotor is running at synchronous speed. Now, for positive half cycle of the AC supply, here the stator north pole is attracted by the, sorry, here the rotor north pole is attracted by the south pole of the stator. Similarly, the south pole of the rotor is attracted by the north pole of the stator. Due to force of attraction, the rotor is going to experience torque in clockwise direction. Now, in this scenario, as with the external force, the rotor is rotating at clockwise direction. So, in the time interval in which the polarity of stator poles change, rotor also advances through one pole pitch, and due to rotation, the north pole of the rotor is now in this downward position, and the south pole is now at the upward position. So, in the meanwhile, the polarity of stator pole is reversed, and in this reversed position, again, the south pole of this rotor is attracted by the north pole of the stator, and similarly on the bottom side, the force of attraction is taking place, or again, the motor will going to experience a torque in clockwise direction. So this is how the interlocking of both these fields takes place, and after the removal of external force, the rotor will continue to run at synchronous speed. This synchronous speed is given by this relation 120 F upon P. Here, one thing we have to keep in mind that this synchronous motor either operates at synchronous speed, or the synchronization or the locking between these two magnetic fields get failed. With the application of load, there is no change in the motor speed. And if we have to change the motor speed, then we have to change the supply frequency. Now, the various methods with which we can start the motor are as follows. One is by the use of pony motor, by the use of damper windings, and third method is by the DC machine. Pony motor is a small size motor having speed greater than the synchronous speed, for which it is utilized as a starting mechanism. The pony motor is directly coupled to the rotor of the synchronous motor. First, supply is given to the pony motor, and the rotation of the pony motor is feed to the motor uh, synchronous motor rotor of synchronous motor. Now, as the rotor is running at synchronous speed, its field winding is energized, and after that, supply to the pony motor is cut. And once the synchronous motor starts rotating, this pony motor is connected to the motor shaft or it acts like a mechanical load. So, this type of starting, a additional motor is utilized. The second method is the starting of synchronous motor with the damper windings. This damper winding is the most suitable method and it is mainly used because with the help of damper winding, there is no additional machinery is required. Damper windings basically damper are the bars, short circuited bars similar to the squirrel cage rotor, which are inserted in the rotor of synchronous motor uh, by cutting the pole face of the rotor. Here we can see these are the damper windings. Once this synchronous machine is to be started, first the three-phase AC supply is given to the armature windings. As the three-phase AC supply is given to the armature winding, the armature field is synchronously rotating in nature, and in this rotating magnetic field, the damper bars act like a squirrel cage rotor, and the motor starts similar to the three-phase synchronous motor. As we all know, the speed of three-phase induction motor at no load is almost equivalent to the synchronous speed. So with the damper bars, the synchronous machine starts in a similar fashion as a three-phase induction motor starts. So due to damper winding, the rotor starts running at a speed very close to the synchronous speed. Then by providing the field excitation or DC supply to the field winding in the rotor, we synchronize the stator and rotor magnetic fields and magnetic locking takes place. Now, one more advantage of damper winding is as the starting process is complete, once the stator and rotor magnetic fields get interlocked with each other, the damper windings are automatically cut off from the circuit. As when both the fields interlock with each other, the damper bars also starts running at synchronous speed, and at that time for these damper bars the stator magnetic field appears stationary. So the added advantage of damper winding is no additional machinery is required and they are automatically cut off from the circuit once the starting process is complete. Now, the last method of starting is the DC machine. Here we can see that a DC machine is directly coupled to the rotor of synchronous motor. First, this DC machine is operated as a motor, and due to the rotation, the rotor of synchronous motor attains its synchronous speed. Then this field winding is energized and synchronization takes place. And then supply to this DC machine is cut off. Now, added advantage of DC machine is that the rotations from synchronous motor can be fed back to this DC machine and during normal working of this synchronous motor, this DC machine can act as a generator and with this we can generate DC output and that DC output can be utilized to energize the field windings connected on the rotor of synchronous motor. So these are the various mechanisms which are used for starting the synchronous motors. The synchronous motors, various applications are, the very first application is, it is used for power factor improvement. When the synchronous motor is operated in overexcited condition, it takes leading current and due to this, it can be used for improvement of power factor. When this synchronous motor is used for power factor correction, then its name is known as synchronous condensers. The advantage of synchronous condenser is they can be used for very wide range of power factor correction, whereas the static capacitor banks has a fixed ratings. The second advantage of synchronous machine is the synchronous motor operates at a constant speed. So various industrial application where this constant speed drive is required, we install synchronous motors. For example, in textile industries, in paper industries, where the raw material has to pass with various through various rollers where the quality of product can be deteriorated with the variable speed. So in such scenario, we used synchronous motors as the motor speed is almost constant. There is no variation in motor speed. And third is for voltage regulation. As we have already discussed in overexcited condition, the synchronous motor can take leading current. So this can be utilized for improvement of power, voltage in transmission lines at the power stations. So these are some applications of synchronous motor. These are the references which are used for making this video. I hope you have enjoyed watching this video. Thank you for watching this video.